So some of the students that I had in my class, they knew what I was doing in the research, and they were really bored by their project. We had a visitor from NASA that came here, and she was giving a talk about like how we could maybe think about building smarter capsule, and that really got them excited. So they started doing this capsule then. So basically every year there was always at least one group that was participating in doing that. So that just kept growing and growing, and then we got some funding. So at that point, it was more interesting. So instead of just building mock-up capsule, we had to build an actual one. And then it culminated with this project, which was through NASA EPSCoR, which allowed us to go to the space station. It's very expensive to send something there. It's very expensive to have an astronaut do something. It's very expensive to use electricity. So our project had basically a 2 minutes usage of astronaut time, no power, and very low mass.
So the capsules are sent to the ISS on a resupply mission, and they remain on board the ISS for several weeks until that resupply mission is over. And at the end, that resupply vehicle is then undocked from the ISS, and our capsules will be placed inside there. Eventually that vessel is deorbited, and the purpose of that is to burn up that vessel because it's also full of trash from the ISS.
When everything is exploding, they're gonna survive. They're meant to survive, and they're in shells. The shells are gonna open up.
At that point, they'll then re-enter the atmosphere and then collect the data and transmit it down to us. The main goal is to gather temperature measurements from the capsule as it re-enters the atmosphere. We want those temperature measurements because that will tell us how well the heat shield is performing as it re-enters the atmosphere. This will help us design new heat shields. It helps us just evaluate the performance. Additionally, it helps computer simulation people to compare, actual experimental data to their simulations.
All 3 heat shields were provided by NASA, and the goal here is really to be able to measure the thermal performance of these heat shields. So that links back the research we're doing, of course, which is modeling heat shield through now getting experiments.
I was very much interested in math and physics, but I also grew up playing with Legos. I enjoyed just going through processes and following step-by-step instructions, and I also liked solving problems, so that's why I chose mechanical engineering. Mechanical engineering is very hard. The coursework is very rigorous. They have lots of hands-on projects which teach you the concepts that you learn in class. The hard work pays off because at the end you have a good paying job and you have a really fulfilling work. Working with Dr. Martin has been really great. He's been a very clear communicator and always responsive. Dr. Martin also provides me with lots of research opportunities and projects which have greatly helped me expand my knowledge of engineering. It's really exciting to work for NASA and be involved with NASA projects. I really enjoy the hands-on aspect of this project. I get to build these capsules, I get to test them, and I get to use just basic mechanical engineering problem solving, which I really enjoy